Hello everybody, my name is Matúš Pivovar. I'm PhD student in Institute of Forest Ecology, Slovakia Academy of Sciences, and I would like to first thank you for every presentation because everyone inspired me very well. And now I would like to introduce my research. I am focusing now on spectral signature mostly. It is a discrimination spectral signature by hyperspectral imagery from aerial imagery. Thank you. And, and so we can go on. I click here. Oh, I would like to first introduce you with my content. Firstly, we will talk a little bit about another project, Project Extemit, which is part of project of CZU in Prague, and bark beetle mechanism. And then I will show you my hyperspectral imagery computation, and then analysis and results of spectral discrimination. This is exactly another angle of view. This is no prediction, no classification. This is mostly about statistical tests. And then conclusion. So I forgot this is not working. So picture of Extemit. We try to find difference between chronic and acute stress, and what is what I will tell you later. So now you can see here the bark beetle mechanism, which was constructed by my supervisor, Rastislav Jakuš, and how this bark beetle mechanism is working is visualized here. There is some random landing and primary attraction, where random landing, we can tell its initialization phase, and the primary attraction could be spreading. The primary attraction is not randomized. This bark beetle directly goes to the straight infested forest. So the Extemit is focused on bark beetle spreading and researchers are focusing on genetic, chemistry, and remote sensing things. And as you can see on this picture, there in Czech Republic is so high amount of infested and salvage trees affected by bark beetle. Our reason of interest is focused on, let's say, eastern part of region of Prague. There is coastal na Černými lesy, and you can see our sites. Also, Alexander Karpov showed you yesterday these pictures, very similar pictures. We divided our sites on chronic stress, as you can see here, where under canopies of monoculture of Norway spruces is the roof, and this roof stress the trees of drought. And then below picture we have forest edges when is acute stress, and mostly this stress is affected by sun radiation to the bark of Norway spruces. And the third picture shows us the installation of bark beetle boxes from terrestrial measurements. So we tried to make some establishment from 2018 to 2023. For this presentation is important just plot 1, 2, 5, and 7 and 8, because plot 3, 4, and 6 was terminated over time. Now we will talk something about our hyperspectral. Same, Alexander told you something about our sensors. I am using mostly optical or only optical sensors, but we have also thermal sensor. There is CASI and SASI sensors from almost 400 nanometers to 1000 nanometers, and then is SASI from 1000 nanometers to 2500 nanometers. The difference between CASI and SASI is in spatial resolution, which CASI has 0.5 meters spatial resolution and SASI 1.25 meters spatial resolution, and we try to find some spectral differences in plots. You can see here on map where the plots are. The weather when the Czech globe was required images was in one image per 1 month. So one image was in June, in July, August, September, October in 22, and then we also had required image from 2023. You can see the weather was almost every time sunny, and just in July 2022 was image captured so early morning, approximately at 8 a.m. So now I would like to show you our subplots. We measure tree positions of our trees. In every time I had to, because this tree position was captured in 2023, I guess, some in middle of summer, and it was very tricky to find these trees over time. I mean, in 2022 on previous images. So you can see these plots from the previous table. ABCD is roof, edge, interior, and control. Control is just controlling the interior trees if there is some spectral discrimination or not. My research or our research questions was focused on physiological status of chronically and acutely stressed trees and groups changes seasonally. Also, we would like to find some typographs, I mean, bark beetle outbreaks there, but there was not really well captured this information from our research. And also, which is very important for further analysis, which spectral is good for producing spectral indices or another information. I don't use this full potential of hyperspectral imagery because there was 100 bands and it was so difficult. And this is my inspiration, where first author is Professor Ronkavara and also Ropenasi. And in this research was also the spectral discrimination found. So my hypothesis with significance level 0.01 was focused on non-parametrical statistical tests, where in null hypothesis we declared there is no spectral separability between the subplots, and alternative hypothesis tells us that we find some stress between some spectral differences between acute, chronic, and non-stress sites. Together was 193, and this is my workflow on 5 locations, 6 days. This amount of trees we extract spatially these canopies, and for each subplot, and then extract spectral information from these pixels, which included in canopies. We used the centroid of each pixel to extract each value of bands. Then we used non-parametrical test because frequency distribution was non-parametrical, that there was no Gaussian distribution. So my analysis, as you can see in Calci, I divided Calci and SASI through the frequency distribution because this merged image preprocessed was not so good, so I used the base divided to Cassie and Sassy, and we can see by the KDA curve these two peaks. So which tells us is non-parametrical or also Sassy. I'm showing you just one date, but I had I use this frequency distribution and another analysis for every day. And I choose Kruskal-Wallis test like non-parametrical test for findings. If there is some spectral differences between roof edge interior and control, and there was, but from this plot we don't know where exactly is the differences. And I used frequency plots for findings. These pairs, there was some difference, some discrimination of spectral signature. And I used Mann-Whitney pair test and also Dun test. There was some mistakes. If combinatorics was fully, this bar was to the 6, this means there was also spectral difference between control and interior, and this is false positive information. So we use Conferoni correction for removing this false positive information. We can see the main spectral signature of our Spruces. We expected right information that the healthy trees in interior are with higher information of reflectance. Then in the middle is edge, which means acute stress, and below is the roof with chronic stress with drought. Mainly in near visible spectra with between 700 nanometers and let's say 1,300 nanometers, and then also some moisture or water content has also differences between 1,500 and 1,800 nanometers. And here, this is my main result of my research, of our research. There you can see the pairs of spectral differences when on vertical axis is temporal resolution, and on horizontal axis is spectral resolution. And control and interior is crucial to be tells us there is no difference. And as you can see in October 2022 and September 2022, there is also difference between control and interior, and I think this is also mistake, false positive could be. So we will remove this information in further plots because could be mistake. Then we have control versus roof plots when we can see this discrimination mainly in red edge position in each 6 dates, which means we can use, but also in water potential and other RGB spectra, mainly in August 2022 and 2023. This is crucial information that August was has the best results in each year's wood. And for further analysis, probably Alexander Karpov or somebody else can use this information for producing vegetation in detail. and so on. There we have also control versus age, when this acute stress was also in a visible spectra and a little bit in water content spectra. And there is differences. There are differences between roof and edges also in August in 2022 and 2023, very well discriminated through the all spectra. We would like to find some relation between spectral signatures, discriminants, and some terrestrial meteorological data. We had a meteorology station in Onje, which is approximately 10 kilometers from our sites. And I would like to say, through these basic heat maps, it was computed 18 days from day when the image was captured. Why? I will tell you in the next slide. Now it's very important to say just August, when the mean of these 18 days of maximum temperature was about 21 degrees of Celsius. There we can see that then spectral signatures react to chronic or acute stress of drought mainly, and then when precipitation is above 80 nanometers, this cumulative sum of precipitation is about 80 millimeters. We can see some story behind. So about the solar radiation, I didn't find any relations, and humidity neither. And my final slide is about precipitation. We tried to find by Tanabo dry index, which is computing by precipitation, temperature, and global radiation. And the dry index was equal 0, which means there was no longer time period of drought during both years. In yellow, you can see precipitation in 2022, also images captured in 2022, and blue color shows us the precipitation in 2023. And my conclusion are the null hypothesis was rejected. The change was demonstrable during all spectra, mainly in August 2022 and 2023, but also we can see some differences in October and September. And what is very important, and I'm not sure about it, is bark beetle attack activity influenced by seasonal changes in differently stressed trees. I'm not sure if I can answer for this question. So I will deal with this in further. That's all. Thank you for your attention.